Hi everyone. Today's lesson is about exponential equations. Now it's most important that we're comfortable with logarithm notation. So let's just, where's my biro? Here we go. Let's just make a couple of notes here. This is a logarithmic equation involving the word logarithm, and this is an exponential equation involving an exponent. Now, often we start with an exponential equation, and in order to solve it, we turn it into the logarithmic form. Let's note that b, the base of the logarithm, is still the base of the exponent. Let's also note that the index, or the power, that's equal to the logarithm. You see here, x equals the logarithm of a. So the word logarithm is really synonymous with exponent or power. Logarithm means, or is the same as, or is equivalent to exponent. Now let's see how we use this. If, for instance, and as I said, most of the time we will start with an equation in exponential form, and to solve this equation we'll turn it into the logarithmic form. So let's start with a fairly straightforward one first. Let's imagine we had something like, here's a good one, 2 to the power of x plus 3 equals 64. Now, in order to solve this equation, we're going to have to write it in logarithmic form. And this is what we do. We write the logarithm. Now, the base here is 2, so the base of the logarithm will be 2. Logarithm is another word for exponent. The exponent is x plus 3. So x plus 3 goes to the right-hand side. The logarithm is the same as the exponent, and the 64 is the value that we're working on. So the logarithm of 64 to base 2 equals x plus 3. Now, if we could think of the power of 2 that was the same as 64, we'd be in business. Sorry, a bit too soon for this yet. Without a fancy calculator, I'll have to convert this to log 64 divided by log 2, and this is no longer base of 2. The logarithms here are common logarithms, and that's the key that I have on my calculator. So if I want to know the log 64, I just type this, and I put that over the log of 2. It gives me the answer 6. So I'll replace that. 6 equals x plus 3, subtracting 3 from both sides, x would equal 3. Now, what does that 6 actually mean? That 6 is the power that we would need on a base of 2 to give the answer 64. And if you think about it, 2 to the power 6 is actually 2 times 2 times 2, that's 8, times it again, and 8 8s is 64. So that's how logarithms work. And that's an example of a logarithmic equation. Now let's go for one slightly more challenging. I will find a better one. Here's a good example here. I've got 0.9 to the power of 4x plus 3 equals 25. So it's an exponential equation because the pronumeral x is part of the exponent, and I will solve this by writing it in logarithmic form. So here I go. The logarithm, now what's the base in this equation? The base is 0.9. I can use 0.9 as a logarithm base. The logarithm of 25 equals, and the exponent is 4x plus 3. Remember, exponent is just a different word for logarithm. Here I go. Now, I'm not going to attempt to imagine what numbers I need here. I will write this as log 25 divided by the common logarithm of 0.9, just so that I can get my calculator working on that. Let's grab my calculator. Now I'll just go back and change that one to 0.9, and up here in the numerator, that's now 25. Common log of 25 divided by common log of 0.9, negative 30.551, if I round off a bit. Negative 30.551 is approximately 4x plus 3. Subtracting 3 from both sides, I would have negative 33.551. And I was about to write 4x, then I just realised I could divide by 4 at the same step. So let's perform that. Now here's a tip. Don't clear the calculator. Reuse that previous answer. What did we do? We subtracted 3 from that. There's my negative 33. And then I divide by 4. So my result is negative 8.388, approximately. Negative 8.388 is the approximate answer for x. Remember, x is the solution to this equation that we have here. I could always use my calculator to verify that solution by entering the left-hand side and seeing if I approximately get 25. I'll just have to remember what the solution was. So 0.9 to the power of 4 times negative 8.388, I think that was it, plus 3. And I'm very close to 25. The rounding off has made a small discrepancy, but that's definitely close enough to confirm that my answer was correct. So that's it for today. Solving exponential equations by changing from exponent form into logarithm form. And this is a handy little step here as well to use on the calculator. Thanks for watching.